Hi, everybody. Nice to be here with everyone here. So today we are glad to have Kai Chao, the developer advocate from Parity, here to share with us a topic that we are always interested in. So we know that Substrate is always good for the public blockchain, so which is like well known for the Polkadot and Kusama, right? But a lesser known fact is that Substrate is start to begin to be able to have the capability of running a consortium chain or a permissioned chain. So Kai Chao has been doing some work about how to make Substrate being able to run a consortium chain and permission chain. So today we are glad to have Kai Chao here to share this with us. So I'll give the time to Kai Chao.
Cool. Thank you, Jimmy. Can you hear me well? Hello, can you hear me well, Jimmy? And anyone else? Okay, cool. I will start my slides. My name is Kai Chao from Parity Tech. Today, our topic is about how to use Substrate to build a permission network. So today's topic will be mainly cover three aspects. One is what's the difference about public blockchain and permission blockchain or consortium blockchain. Another one is how we can use Substrate built-in module, which called node authorization, that to build a permission network. The third one is that we will check the deep dive into the code changes for this feature. Before we talking more about the permission blockchain, let's talk about public blockchain first. As you already know that the public blockchain has been evolved in the past 10 years. There's a lot of successful examples or explorations like the Bitcoin as a global payment network, and the Ethereum, which is a smart contract platform, which can execute the unstoppable scripts execution, and it's pretty complement. And Polkadot as a cross-chain network has a few advantages over Ethereum, like the shared security and the cross-chain message passing. Also, it has much more. It's much more scalable than the Ethereum one. For public blockchain, the features usually include that it's free to join as node operators or as users. You can either to if you are joining a proof of work network like the Bitcoin and the Ethereum one, that you can run your own miner to secure network. Or if you are using Polkadot, you can run your own validator to secure network. You are free to join as a miner or validator. Also, you don't need to always run a validator. You can also run a normal node, which can simply propagate the transactions and the query state of the blockchain. For public blockchain, there's a vision that to achieve highly decentralization, but in reality, this is not always the case, since the most big miners and mining pools have a lot of voice in the Bitcoin and Ethereum. And for the proof of stake chain, the big players have much more fund, have a big voice than the normal user. And the public blockchain usually have a native token which help to facilitate the usage of the network and to incentivize the network to be more secure. The public blockchain are good for scenarios like we said is good for global payment like Bitcoin and Ethereum. Specifically for Ethereum, it brings another another service model, like much like a serverless module. It enables trustless and 7+2 22 hours highly available logic execution. With these features in mind, we can actually enable a borderless collaboration across the world. Like you can send a transaction or pay some money to people in US from Germany, and you can build a decentralized organization from different countries and to incentivize your team members to work on a common goal. Now let's switch our focus to a permission blockchain. This also has a name that which is a consultant blockchain. It gets its attraction beginning in 2015. There's a few framework or technology behind this field. One is Fabric, which is originally built by IBM and contribute to the Linux Foundation, and it's under the Hyperledger Hyperledger group. Another one is Quorum. Is if I remember correctly, it's a fork of Ethereum 1, and built by JP Morgan to add a lot of the enterprise features. I think in 2019 it was contributed to the Quorum is transferred or acquired by the Consensus Foundation. Another one is Substrate. It's very flexible to build blockchains. Actually, a permission blockchain can be easily achieved using Substrate. For permission blockchain, the features include the user or the node operators need permission to join the network. You are not free to join for the network. You are not allowed to join. You need to get permission from the an administrator of the network. It can be a people or an organization. Depends on your design and requirements. Usually, it needs to conform with the regulation and the administration requirements. Sometimes the consultant blockchain is used to facilitate with the existing business model. If there's a easy way to integrate with the FAT, there can enable a better user experience and to facilitate your existing business better. Also, for different countries, there is special requirements for the cryptography. Since not every cryptography is secure enough, there's rumors about there will be backdoors. There is backdoors for some cryptography. So different countries use different standards for their security consideration. Such consultant blockchains are good for define the transparent rules and to make this transparent rules execution also be transparent without break the compliance of the regulations. As we already talked about that, the consultant blockchain can facilitate the existing businesses. Also, I think this is a great exploration since Web 2.0 has been evolved in the past 20 or 30 years. It has a good user experience. It has achieved a pretty good efficiency. So when we are towards into the Web3 world, we shouldn't abandon them all, the old things all. We need to use the Web2 technologies and the business model as much as we can. But still, we need to extract the first critical part, like the user cared about the privacy and some other parts. We can use the decentralized tech stack to improve the user experience and improve the ownership of the data from the user. Since for consulting, yes, sure.
Can you share about what industry currently is using permission blockchain, as you know?
Actually, there's some early exploration for markets in China that are trying to use the consultant blockchain. There's no big success, but I believe there's experience like in the second-hand cars,
okay,
and in the healthcare data for the patients. Yeah,
I see. To reply Thomas' questions, yes, there is special palette that Kai-Chao will share later after this broad overview. Yeah.
Yes, yeah.
Yeah, keep going.
Shall I continue?
Yep, go ahead.
Cool. Cool, thank you. Since there's no, so most of the time we want to have the fat integration, so we probably don't need the native token in a consultant blockchain. Since there is less value to incentive consultant blockchain. Compared with public blockchain, there will be a consultant blockchain will more focus on the user experience instead of the community management and anything else. And it will be less speculated from the user and the community. So let's have a quick overview about the permission, the features to build a permission network in Substrate. Most of the features is already supported, but some of them is work in progress, and some of them is not building by Parity and the ecosystem team yet. So the features includes that you can run a permission validator to secure network. This is being done by the Gotham, which is also from Parity. You should be able to find the tutorial of the code base very easily in GitHub. Another feature is the permission network connection, which is our topic today. I'll be talking about more later. And for the administration, Substrate provide a lot of built-in modules, like the sudo module and other governance-related modules like the collective and console. You can leave the decision or the administration for admin user or for group made up of the different organizations. Sometimes you want to still use the certificates logic to manage the nodes authorization and authentication. So the certificate authority will enable this feature. It's a work in progress in our team. For the specialized cryptography, there's ecosystem team are trying to build that. As I already said, the fat integration, there's no team currently working on it, as far as I know.
What does it mean by fiat integration?
I'm not sure it's have related credit, but I mean the legal money issued by the governments. You can use US dollars or the RMB to use your service instead of use the native token like the BTC or ETH.
Okay.
So this is our today's topic. To build a permission network is pretty easy. You can achieve that in less than 2 hours. You need some pre-knowledge before playing this tutorial. Most of us probably already familiar with runtime development, like you have been building a simple proof of existence palace, and you have been adding another palace to your runtime. Another pre-knowledge is that you need to be familiar with the LabP2B since Substrate is using LabP2B as its underlying network connection. And some concepts needed to know before we start to, but this is also very simple. We will cover it later. So in Substrate, each node and peer or peer is identified by a format called modified format. It's provided by LabP2B. And LabP2B is a library for network peer-to-peer network connection. It's extracted from IPFS project. For multi-format, there's many provide 3 informations. One is IP address. Another one is the port for your application to listening on, just listening on. Another one is a peer identity, which is a unique identifier for your peer in a distributed network. LabP2B use encrypted network connection for between different nodes, and there is a secret key related to one node. And the hash of the public key is the peer identity, which is peer ID for short. actually, the Parity will also have some specific encoding if you want to print it in the console, like the BS58. So this is a simple example for the multi-format. It can actually support other protocol. We just gave actually this example. Substrate has provided a few commands or utility to facilitate the integration with the P2P. There's a subkey utility tool that provide two subcommands, which is generate node key and inspect node key. It can help us to print, get a key for your node and get the peer ID from this key. Now let's see how this permission network is achieved. Sorry, you go.
Oh, before going ahead, there's a question from Thomas. He is asking, is there any production implementation of Substrate as permissioned DLT, distributed ledger, even some MVP?
Production, as far as I know, I don't know if there's users are trying to use production, but there is people are trying to use this but I'm not sure if this landed in production or
not. Let me add also more context is that in fact we are trying, like the Asia team is trying to push the permissioned network side of Substrate in China. So we are also like trying to push this more. Like may not be production scale, but it could be like MVP or like in some kind of trial scenario. Yeah. And another question.
To your questions, actually the for the above question, I think this feature is still pretty early and it's a proof of concept. It's just demos how Substrate can build such a network, but it's unaudited yet, and the benchmark is not finished yet.
Okay. And another questions from Sacha.
Is there another question?
Oh, there's a second question. What governance models are most widely used for consortium blockchain in production? In your experience, what should consortium chains optimize for?
I think it depends on user requirements. If you are using it in a single organization, I believe a sudo module should be fine to do this administration. But if this is a group or a union, like a few organizations to participate in this network, you probably the government council, or not a council, but like another collective group. You can name it anything else like a specific group name and give this specific group name specific origin to do this operation to manage the connections of this network.
Okay. And then another another question from Dan. Why is the China team so interested in using Substrate?
Yeah, sure.
Why is
that's a great question. Yeah.
Using Substrate for private network?
Yeah, I think we have a discussion in our team that there's, as I mentioned earlier, there's a lot of explorations for how blockchain can do good to normal people, right? For different markets, for different places, they have different rules, game rules, right? In China, there's actually pretty has very high regulation, and if you want to land blockchain technology in a specific field in this land, in this region, you need to make it modify blockchain's concepts. Remove the parts that is not conform with the regulation, but just use the part that not obey with this regulation. And permission network or consultant blockchain is much more easy to build such regulation, fit to such regulation. Since you can have an administration account, and you can you don't need to maintain a highly decentralization network. You just need to make the rules transparent, make the transparent execution as efficient as possible, and improve user experience. I think it's pretty interesting, and from my point of view, and in our team, we agree that this is a pretty practical way to land blockchain in this market.
Yeah, and another note I want to add is that not sure if like how well known this is, but the Chinese government has banned public blockchain with tokens. We see that the advantage of using blockchain, right? Like the immutability, that they cannot modify the records once it is written there. So it is good for a lot of record keeping. So we are thinking how to put this in use. And one use case, actually one common use case, would be apply this in a lot of different industry, like simply as supply chain, keeping track of the cargoes from one place to another, or keeping track of the authenticity of products, to make sure that the medicines or a certain product is authentic, all the way starts from the manufacturers and down to the hand of the consumers. So we can use a blockchain to track all these things. Yep. I would let Kai-Shao to continue his presentation first.
Cool, thank you. So let's continue. So the feature, the permission feature, is partially permission connection feature in Substrate is provided by this node authorization palette, which is a new palette. In this palette, it simply stores all the allowed connection between peers. So it has a map. It has a collection of maps. The key is the peer ID of one node, and the value is the allowed connections or the targets peers that it can connect to. So each node in Substrate is identified by peer ID, which represented as a vector U8 in runtime. And in this node authorization palette, we gave each node an owner. So if and the owner of the node can make additional connection for this node, like it can connect to 10 other nodes. Just the owner can do this centralized configuration for this node. If you want to join permission network in this palette, there's two options. One is you can join as a well-known nodes, and the connection between all these well-known nodes is allowed. Another option is you can persuade the owner of one node that you can connect to his node, and he's allowed you to connect. So then your connection will be allowed, and you will be able to join the network. But you can only connect to such one node but can't connect to other nodes without furthermore connections. In this palette, it's used Origin worker to command your node from runtime. Since the allowed connection is defined or stored in the blockchain state, but the node has its own perspective, right? Then you need a bridge to make this possible, which is the Origin worker here. If the node didn't skip this Origin worker's execution logic, then it will use this configuration in the runtime or in the blockchain state to make connection in its own network configuration. But if the node decides to skip the Origin worker or didn't want to follow the rules in the Origin worker, it can also connect to any other node without conform to the runtime storage. But by default, we assume that most node is honest and don't want to make any harm to the network in the permission network.
On the third point,
So that's
when you say on the third point, when you say well-known nodes, are they just like specified in the chain spec, or what are the well-known nodes?
A well-known nodes is like permission is so the basic definition is that the connection between well-known nodes is allowed, right? You have 3 well-known nodes, and they can connect to each other. It's there's a scenario that you have you want to form a permission network which has 3 organizations, right? And each organization will have one represent node, and this node can join this well-known node, and these 3 nodes from different organizations can connect to each other. But in a single organization, it has furthermore nodes to join the network without connecting to the nodes from other organizations, but just connect to its own well-known nodes from this organization. We'll have a topology picture later.
Are these well-known nodes defined in the chain spec or the Genesis block at the beginning?
Yeah, if the nodes is running for the validation or used for form the participants block authorization or finalization, you need to define it in the Genesis spec. But you can change it later, like the normal state changes.
Okay.
Cool. Let's have a look at the code about how to add this palette. It's pretty simple. I think it has less than 20 lines of code. So we first want to import this. Probably you are able to see. First, we add this BS file 8 in the nodes cargo.toml so that we can decode the printed PRID to bytes array. And in the chain spec, we import the node authorization config. As Jamie mentioned, that we need to add the Genesis permission node that's participating in the network to the Genesis config. And in this Genesis config, we have a node authorization config, which has a list of nodes that can join the network's connection in the Genesis block. The first element of this tuple is PRID, and this PRID is wrapped by an opaque PRID. And the element in this opaque PRID is a vector U8. So we want to use BS file 8 to decode this printed PRID into a bytes. The second element of this tuple is owner of this PRID. So we are using the indole account, the first element of this indole account, which is Alice. And for the second one, it's similar, but we use this owner as Bob. And in the runtime, we just add simple steps to add another palette, the palette node authorization. And in the runtime lab.rs, we add ensure root. We are using a simple governance model with a pseudo module. And we implement the node authorization trait for our runtime. It has a few type names. One is the max well-known nodes, which is the max number of your well-known nodes. Another is max PRID length. Since our PRID is represented as a vector U8, we want to give a bound for this vector to not ruin our blockchain with unlimited vector provided by the user. Another one is we have a few origin to do a specific operation like add origin, which is used for add a well-known node. And the remove origin is to remove a well-known node, and swap and reset is similar. Ensure root is we just imported to give the special origin that can use by specific operation. And this we just imported in the construct runtime. This is how you can add this palette in from the node template code base. Next, let's see a quick demo about how to set up 4 nodes to form a permission network. There's next steps. I will go through one by one. So basically, we will set up 4 nodes: Alice, Bob, and Charlie. These 3 are well-known nodes, which is allowed to connect with each other. Another one is Dave, which only allowed to connect with Charlie. Both Dave and Charlie need to configure a special, or not special, but additional connection to each other. Let's have a look at how we can start this network. Can you see my terminal, Jimmy?
Yes, I can.
Cool. So first, let's start Alice. I already purged the chain, so it probably is clear now. So we are using the local chain, and we gave it a path for the data stored. And this is the first node we want to start, which is Alice, and use a private node private key, which is this one. And we have a specific peer-to-peer network connection port and the WebSocket port. Let's start first. As Alice and Bob is already configured in Genesis service, Genesis spec. Now we are already start the Alice node. It has no peers and no block generated. Let's start Bob. Bob is similar to Alice. It's just use a different path and with different validator name and different node key. Port, the peer-to-peer listening port is also different. Let's start Bob. You should be able to see that we already have a one peer for each node, and the block is generated, and probably gonna finalize. It's gonna finalize now. So now we have these 2 nodes started already. Let's check the blockchain state to see what's the well-known node stored in this blockchain. Let's go to the X. We already connect to the network is using the local testnet. The current block is 10. Let's go to our chain state. Actually, you need to do a special config, the type registration in this page, which adds this field peer ID, which is a vector U8 tuple. And we go to our chain state, check about the storage in our node authorization module and the well-known nodes. You should be able to see that there's 2 well-known nodes, which is Alice and Bob. You can also query the owners of the specific peer that we use. This one. This is the account ID from either Alice or Bob. You can check from the account page, but we don't do it here. Now let's start Charlie's node. It's similar to Alice and Bob. We just use a different validator name and different node key. Now Alice node is started, but there's no peers, and it's not syncing since
Hello? Hello, Kaichao? I cannot hear your voice though.
Now or?
Oh, it's fine. Yeah, your voice
Hello?
is written. Yes, I can hear you now.
Okay. Okay, it's probably my network connection. How long did I miss the
So just now,
network?
Charles. So you run the Alice and Bob nodes, they're fine. And then when you get to the Charles node, it's kind of
Yeah.
hang there.
Okay, cool. And this is Charlie's node. And Charlie's node has no peers now, and it's not syncing to the network. So this is because we don't have done any further configuration to add Charlie to this provision network. So let's now add the Charlies to the well-known nodes to let him to participate in this network. As we already see that to add a well-known node, we need the add origin, which is the root call. Let's use sudo call to stimulate this root call. We need to call node authorization and add a well-known node. I need to find the peer ID of Charlie, and I need to go to the tutorials, since I already put the peer ID in the tutorials. You can hear me, right, Jamie?
Yeah, I can hear you.
Cool. Let's find Charlie's node. This is Charlie's peer ID. We need the hex format. Let's copy it and put it here. This is the peer ID of Charlie, and the owner is Charlie, of course. And let's submit a sudo call. Before we say and submit, let's check it again in the terminal. It's still no peers and no syncing logs. Let's submit and see what happens. Cool. You can tell that there's two peers in Charlie's node, and it starts syncing here. Let's check Alice and Bob. Both Alice and Bob now have two peers, which from one peers to change to two peers. It's a good sign that this demo is working. Next, we need to start Dave's node. If you let's see the diagram. So we need to start Dave's node and make it connectable to Charlie. Now Alice, Bob, and Charlie is already connected to each other. We need to add Dave's node. Let's start Dave's node, similar to the 3.1, but we use a different name and different key. Now we started Dave's node, and there's no connected peers and no syncing logs. Now let's see how we can quickly configure the Dave's node to make it connectable to Charlie's node. We don't need sudo call this time. We need the normal call. Let's first use Charlie to add a connection, additional connection from Charlie to Dave's node. And the peer ID of Charlie's node is here. And the connection the Charlie node can connect to is that Dave's node. And the peer ID of Dave's node is here. Let's copy it. And let's submit the transaction. Cool, it's added. Let's see what happened. You can tell the Dave's node has one peers, and it starts thinking, but it's not only Charlie is allowed Dave's connection, but Dave is not allowed connection from Charlie, so the network will still broken after a very quick, connection. There's no further connection because Dave didn't finish his configuration. I'm not sure if this is clear. If there's questions here, please let me know. But we need now we need to configure Dave's. Is there questions?
Oh, is it expected? Like I see that from in the console. If you get back to it from one peer drop back to 0 peers. Is it expected?
I think so. But I'm not very sure about the behavior since we expected the connection is not allowed at first without configure both sides. But actually, the connection can be allowed once or twice, just a short of time if you configure one side without configure another side.
Okay.
I can't explain the behavior now, but it's we can definitely improve that without connection, disable the connection without configure both sides. That should be a much clearer or much better experience from my point of view.
I see. Okay.
Now let's add Charlie's additional connection for Charlie's node for Dave's node. But before we add connection from Charlie to Dave or from Dave to Charlie, we need to claim this Dave node for Dave. We are using Dave's account and we claim node, and the peer ID is Dave's node. Since this is local, that no one is claim this peer first. But if this is a Parity network or if this is an open network, you need to claim it even before you start your node. Yeah, this is Dave's node. Let's claim Dave's node for Dave. It's now claimed. We need to add connections for Dave's node. And the allowed connection is, of course, the Charlie node. Let's submit transaction. Cool, is successful. And let's see what happened. There's no there's no connections because we are lack of the current state of this blockchain for Dave. From Dave's perspective, we need to stop it, and start it again. You can remove this overtaking worker always flag so that it don't use this permissioned network to make its configuration, just to sync the network. But let's try to not remove it first. Now we can see that the Charlie's node have 3 peers. Now one is two of them is Alice and Bob. Another one is Dave's node. But Dave only have 1 peer with this Charlie, right?
Okay.
And we have Alice and Bob have 2 peers. Right. And so this is exactly what we expected in this diagram.
So the Alice and Bob do not see Dave, right? Dave is only visible. Dave is only visible by Charlie. Okay.
Yes. Okay. Since we are using local network for this demo, it can be and the local network use MDNS to discover new nodes and try to connect to the new nodes. But if you are using a remote server for your multiple nodes, for each node have its own server, you probably want to use the -- reserve nodes to specify the nodes you are allowed to connect to first sync up the network to get the latest state of this blockchain without enabling object worker. As we already told, we are using object worker to command our nodes connection from runtime. Without enabling the object worker, you can skip this feature and connect to any node that you are allowed to connect to.
Okay.
Is there any questions so far?
There are two. Oh, actually from the same person, Louis, I guess. He is writing a custom-based consensus.
Mm-hmm.
Is there any tutorial on that? And will that means that I can remove the default consensus out of the code? My consensus is proof of AI.
Proof of AI is that artificial intelligence or something.
I guess so. Yeah.
Okay. I think for the customized consensus in Substrate, there is actually Substrate splits the block production and the finalization to two parts, and there is a clear trace or interface to define your block production logic or mechanism. There is Aura, which is authority-based block production algorithm, and there's the BAPE, which is randomly selected validator to produce the block. And there's another one. I think it's the POW based. You can use some. You can leverage this interface to build a POW algorithm using algorithm. I think the project is using that is called Loop. If you are trying to customize your consensus, you can also like to split the logic from block production to the finalization. If you're doing finalization, you can just use the block production part. You just use the interface extracted by the in the lower level in Substrate. For the tutorials, I don't think there is a clear tutorial, and there's a instant seal about the block production in the recipes code base, but I'm not sure there's a detailed tutorial or not. Probably Jamie know more about it.
Yeah, so actually we have this Substrate recipe. I'll also paste the link in the chat section. They are like customizing the default. I believe default we are using a POA, proof of authority, maybe. But then we're trying to customize like either using a basic proof of work, and then we have a hybrid consensus there. So you can take a look at the code there and see how, like, which part that we plug out, and then which part that we plug in the additional code there. Yeah, have fun with that experiment. So,
yeah, definitely expect to see more about your code about adding the consensus.
Yeah. All right. And then there's a deep dive.
If there's no more questions?
No more questions.
It's okay. This is actually let's have a quick look about the code that how this feature is implemented in Substrate. As Substrate is often talked about that highly scalable and highly customizable. Let's see how this is going to achieve in this simple feature. You can search this pull request, and there's a related issue and some context description about this issue and the solution. have look at the code first. There's no more to see for this configuration. And in the as we already talked about that, we are using the off-chain worker to command the network from the runtime. And this is what we need to change in the network layer. This the service.is is like the entry point or the consolidated service for the network's logic. And we expose some interface from this service, from this network service. And actually, this network, the network in Substrate has a specific part, which is a peer set. It has a configuration about which peer is allowed to which peer manages the connection for this peer. We are simply call this peer set its own APIs. And there's another APIs set authorized only. In our demo or in our usage for the node authorization path, we always set it to true. So it's always the only the authorized nodes is allowed to connect each other. And there's some change, but we don't need to care about much more. So this is a API that's used for the off-chain worker. It defines a series of API that can call in the off-chain worker. We define a new one, which is our set authorized nodes. We have a list of nodes, and authorized only flag. In our case, is always true. And this node is that it's allowed to connect for our node.
Let me ask the questions here.
That's a test. Yeah, you go.
Why is it done in the off-chain workers instead of a regular extrinsic?
Sorry, I didn't get your question. Can you repeat it?
Why is it done in the off-chain workers instead of a regular extrinsic?
Yeah. So there's 3 options, I think, for since we the configuration start runtime, right? This is need to get need to reach a consensus between different participants. That's why we need to start in the body state. And there's a few ways you can get this storage in the body state. You can either rest the storage in known case, well-known case, which is like a storage part that you can reach or you can get in the client. And another one, you can use the runtime API to fetch this storage. And the third one is you can use the off-chain worker API to call to bridge the information from runtime or the blockchain state to the client. Extrinsic is used to submit transaction, but now we are not to add more things to blockchain state. We are trying to get the state and to to command the client without submit. There's no way to submit a transaction for that.
I see.
That answer your question?
But then the well-known nodes and who can connect to that peer is safe in the storage, right? It's safe in the storage of a pallet.
Yes.
So when you say like add a well-known node or add
there's 2 concepts in here. It's a well-known nodes, which is a concept in our node authorization palettes specific for our permission network. There's another concept which is called well-known case. This is I'm not sure if I remember it correctly, but yeah, it's a well-known case that has a field key, which is known to the client and known to the runtime code. You can set a specific storage, specific value to this key, and the client can use this key can read this key. Since it's well known, it's shareable from runtime and client. You can read this key from the storage and get its value. This is why I mentioned the well-known keys here.
Okay.
And this is, let's keep on the deep dive in code. This is Chain Workers implementation for our logic. If you're interested, you can read it later, but there's not much more value. We read it here. And let's go to our palettes. This is a pure set. That's why this is where the configuration or the configuration for each node connect to each other configured in the substrate. Cool. It's pretty simple that we add very less lines of code to enable this feature. But most of the code is in our new added palettes with node authorization palettes. But beyond that, the code changes is pretty small, right? And in this palettes, the code in this palettes, we can have a quick overview. Here we have a trace definition, and we already covered that previously. And there's a storage. We have 3 storage items. One is a well-known nodes. It's a set of peer IDs. Another storage is owners, which is a map from peer ID to its account owner. Another is additional connections. Is also a map. Is a map from a peer ID to a set of peer IDs, which is allowed connection from or to. And this is just some error definition. And we have this dispatchable calls. Once add a well-known node to add a node to its own to the network's well-known node set. And specifically, we have a remove logic, and we also have a swap from one node to another one, and we can also reset the list of the well-known nodes, but we require a specific reset origin here. Here we can claim a node for a peer for a node, and the owner is the sender of this transaction or extrinsic. We can remove a claim. Also, we can transfer a node from the owner to a new owner. We can add connections for our node if the transaction sender is the owner of this node, and the connection is a vector of peer IDs. Here we can also remove the connection. This is where we are calling the option worker, using option worker to get the storage state. Right? We get this network state to decode, get our local peer ID, and we using this after we decoded our local peer ID, we using this peer ID and to read from the storage to get the list of connections that's allowed to connect from or to. Get authorized nodes is here. It's simply reading the storage in the additional connection and the well-known nodes here, and do a concatenation for this two for the items in these 2 storage items. That's the logic that implements this feature. Cool. I have finished my part. Is there any further questions?
Yep. Is there any questions from the audience? It is a good time to ask now. No. So there isn't any questions from the audience. Yep. So I guess it is a good learning from Kai Chao that we see that how Substrate. So actually, it's interesting to see that like some nodes, okay, it's like well known among the whole network, and then some nodes is only visible to certain other nodes. Like so it's not publicly visible throughout the whole networks. So it is something that's implemented here. Yeah, and then we have a tutorial. We have a like let me post a link. We have a tutorial about like running your own permissioned network. Let me post a link as well. Hold on. So you guys should go through that tutorials if you are interested in running your own permissioned networks. Here. All right, I guess that's it. Okay, there are some questions. Can we implement a multi-coin on the same blockchain? Can we implement a multi-coin on the same? I guess we can implement a multi-currency. I've seen it. Oh, go ahead, Kai Chao.
Yeah, the balance model. The balance model can have a multiple instance, so it should be easy to implement a multiple coin here.
Yeah. And actually, I just realized that we have like a ORML. Okay, I need to get this link as well. I'll find it. I'll find it and post it in the seminar element channel there. There's a nice open Web3 stack. I think it was contributed mainly by the Akala team. They have written some nice library to build. Right. Dan has shared that to run a multi-currency. Yeah, like in your Substrate node. Kind of joke. Do you have more readable English-like version of that Substrate course Team 1? Huh. Right now, I believe that. Kai Chao, you have anything to say about that? The question from Thomas.
I think there's an English course from Brian. It's also a great Substrate developer. I don't think we have for short term. We don't have to plan to translate or give another page version of a course.
Yeah. Right now, like the Substrate course is mainly targeted toward a Chinese audience, but I also know that we have another Substrate course also like co-authored with a Akala team, or maybe I should say the Akala team co-authored with a Parity. That is like lectured in English. Yeah, and yep. So that will be something you can explore. All right, so I guess that's it for tonight. I want to say tonight because it is evening for us in Asia. All right, yeah, nice like meeting you guys. Yeah, we'll talk to you later. All right, see you guys. Bye.
Yeah, thank you.
Yep.
Bye.